Good morning, everybody. We welcome you to the webinar about our mechanically recycled polystyrene. This webinar will be about 30 minutes, and this 30 minutes we want to guide you through all our activities we have done to reach our objective of mechanically recycled polystyrene. But let me first introduce you the INEOS group. INEOS is a global chemical company, one of the largest currently, and we're present in many polymers. For example, PVC, polyolefins, styrenics, and we have a big presence in the building blocks of PET. But even more people know us from unlocking the performance in sponsoring sports. I think this summer you have all seen the Grenadiers in the biking team, the Tour de France, and we follow closely the Formula 1 with the Mercedes team. But let's now move to INEOS Styrolution. INEOS Styrolution is a 6 billion global company. We are present in all regions with our R&D centers, our production sites, and our sales offices. As you can see, North America, Europe, and China. In China, maybe you have heard about our GV with Sinopec. That makes us the #1 global leader in styrenics. Although we're still a young company, we're only founded in 2011, so that makes us a 10 years plus company. We are present in many product segments: construction, toys, sports and leisure, packaging, automotive, electronics, healthcare, and household. You can see it at the bottom of the slide. Then it is also not a surprise that we have more than 1,500 different products in the markets, and globally we have more than 4,000 customers we serve. This is a very important roadmap for us. In 2015, we started with EcoVadis. EcoVadis is an audit system in the chemical industry that audits our achievements on sustainability. In 2015, we started with a silver rating, and every year we have given us more objectives to work on our sustainability agenda. This sustainability agenda is not only limited to our carbon footprint or our recycling activities. This is also regarding our HR activities, our energy use in our factories. Many topics are covered by the EcoVadis standard. And as you can see, already in 2020, we had the platinum score, and we even improved it better in 2021, which brings us to the top 1% of chemical companies performing in sustainability. And it doesn't stop here. You will see in this presentation that we really have given us again new big achievements in sustainability. You can see them here. We want to be net zero by 2050. You may have heard about our activities in the hydrogen area, but also in the carbon capture area. If we then move to INEOS Styrolution, what's very important for us, that 100% of all our polymers can be recycled in 2025. We will achieve this in projects with our customers together for Design for Recycling, but we also will look at the European guidelines Design for Sustainability. If we achieve this, then it's more easy for us to help our customers to achieve on their pledges they have done to have 30% recycled content in their products. Especially the fast-moving goods industry has made many pledges, and we want to support them that they can do 30% recycled content in their polystyrene packaging by 2025. In general, the INEOS company wants to have 325 kiloton recycled material available in their products. Now I move to Stephanie to explain the recycling technologies we can use for styrenics.
Hello all. So this slide shows the different routes we can apply to polystyrene for recycling. I guess you have already seen some of these circles which go from mechanical recycling up to the most largest cycle, which is gasification of mixed waste. The presentation here concentrates on polystyrene, and this is why you see 5 circles, which is way more compared to other polymers, for example, the polyolefins. Indeed, polystyrene can be recycled in many different ways. For example, depolymerization or dissolution, which are pretty much unique for polystyrene. Today, we will concentrate on the smallest circle, mechanical recycling. The smaller a circle is, the less effort we need to put into the different process steps to make a polymer circular. Mechanical recycling of polystyrene is a highly efficient solution. We think it offers the best time to market, so we can be quick here. And our LCA studies shows that the CO2 reduction, the greenhouse gas footprint, is pretty low for mechanical recycling compared to virgin polystyrene or else to the other routes that you can see here. So there are lots of advantages to concentrate on mechanical recycling of polystyrene. For the next slide, I hand back to Yvonne.
To work on all our activities for recycling, we have to enable the circular economy. And how do we do that? We have to develop new value chains. That means in earlier days, we only used fossil fuel. You see it above. We made monomers. We made the polymers. We delivered our virgin material to our customers. And more or less, we were never involved in the end of use stage. That has changed. And it has given us many new opportunities. First of all, we concentrated on the waste chain to learn about mechanical recycling. Currently, we are able and have access to perfect post-consumer recycled ABS. Coming from mechanical recycling, we add modifiers and our customers can use this ABS, which is performing like virgin-like, back into our products, in their products. Then we developed the household waste chain. Also, many people know it as the mixed solid waste chain. This we did, for example, together with our partner Tomra. We will come back to that later. And we learned how can you sort polystyrene out of the household waste, which is relatively easy. Polystyrene is an easy recyclable material due to their unique density. We will use this polystyrene for 2 routes. For the advanced recycling, which you saw in the slide, depolymerization, but also for the mechanical recycling, on which we will talk today. Then we also have 2 new other feedstock sources. One from the recycled attributed feedstock. This is coming from mixed solid waste, and the bio-attributed feedstock is coming from renewable sources. You also see this little sign, green energy. Already for a few years, we are concentrating on replacing our electricity with renewable energy. And we're happy to say that our Antwerp factory is fully running on renewable energy. And that this year we're also making our German plants running on renewable energy. This is an overview of all the partners we work with. Why do we show this? We are not only doing these projects in Europe only, we're a global company. So you see Tomra for our recycling activities, you see Indaver for our depolymerization activities, Waage for our waste activities, this is all Europe, but you also see Samsung Resin and GER, which are for mechanical recycling projects we run in Asia, and Cyclics in the US. So we really see all our sustainability projects as a global investment in innovation. Then I hand over to Stephanie again.
Thank you, Yvonne. On this slide, starting from this slide, we will now drop a bit more into the world of mechanically recycled polystyrene. This slide is a teaser, let's say. You can see on this picture pre-sorted polystyrene, pre-sorted because you only see polystyrene packaging, and pre-sorted as well because it has been sorted by color. So this is the fraction which has some color in it. We will concentrate in the following steps on the fraction that is white, because once we use white pre-sorted waste, it will give rise to white recycled polystyrene pellets. And that is what you are aiming for, which allows better drop-in. This colored polystyrene waste will rather give rise to a grayish pellet at the end, less easy to use. But how do we do? Next slide, please. Here you see the complete circle of our recycling process when we talk about mechanical recycling. Depending on the country you live in, the used yogurt cup, because most polystyrene in packaging is yogurt cups. So your used yogurt cup will go either in the grey bin, that we do not like that much because the grey bins most often goes into incineration or landfill, or else it will already go in the selective collection scheme. For example, in Germany, it's the yellow bin. That we prefer because then we can put hands on the yogurt cups in there, working together with the municipalities. So they will bring us, we will buy from them pre-sorted waste bales with a high content of polystyrene. On the next little item, you see we will sort again that polystyrene enriched bale. So that's an over sorting, as we can call it, because there still remain some impurities in these bales. For example, on this simplified scheme, you can see some bottles that are, for example, the PET bottles or HDPE bottles that could be in there. We don't want these. We want to concentrate on the polystyrene. But we want to concentrate on the polystyrene that has served as a food packaging. So again, we will sort that waste stream by the precedent application. Food packaging polystyrene, yes, we want it. Non-food packaging, no, we don't want it. So it will be sorted out here. And as shown with the example of the precedent picture, we will sort as well by color. We want to offer you what you can see on the left-hand side of the scheme, a white palette at the end of our process. So we need white yogurt cups and not the colored ones. So once we have put hands on this sorted material, sorted by packaging, food packaging, yes or no, sorted by material, polystyrene, and sorted by color, white versus any other color, we will grind down the material that we have obtained into flakes. These flakes will then undergo a very thorough hot washing. That cleans the surface of these flakes where you can imagine it, some yogurt remainings or other food remainings might stick to. That will all be washed off. We then sort again the washed flakes. We sort them again by color because we want to offer you a white product at the end. I think you have understood that by now. So these white over-sorted flakes that we put hands on will then undergo what we call the super cleaning step. In the hot washing, we have cleaned the surface of the flakes. In the super cleaning step, we will clean intrinsically the material, the polymer. So anything which might stick in the matrix of the polymer will go out thanks to the super cleaning step. That super cleaning step ends with the pelletization step, so that we have at the end what you can see on the left-hand side, white pellets, an easy drop-in solution for your process. You can blend at any ratio that you want these 100% recycled polystyrene pellets with virgin polystyrene. Next slide, please. So where do we stand today with our aim to bring mechanically recycled polystyrene up and on the market? We have a pilot line which is operational. We have projects that are currently being worked on to ramp up the capacity of recycled polystyrene. In order to ramp up our capacities, we need to increase our access to feedstock. You have understood the example of the grey bin and the selected collection, often called the yellow bin. We have done an effort on the engineering. So from the pilot plant, we have gained experience in order to design and engineer now an industrial size plant, including the different steps I've shown you: washing, sorting, and the super cleaning. Thanks to the pilot line, we have put hands on material, super cleaned material, and some of our customers have been sampled and have done trials with that material, successful trials, I might say. And in parallel, because we want the circle to really become a real circle, yogurt cup to yogurt cup, we work with EFSA on the food contact application. So we have submitted some dossiers at EFSA. Next slide, please. And this slide is in order to show you why this effort makes sense. When using recycled polystyrene, we can talk about an abatement of the CO2 equivalent of about 80% compared to virgin polystyrene that is disposed of in the grey bin and goes for incineration, including energy recovery. This is a finding that we have done in our Styrenics Circular Solutions Association, and the complete paper is available. So that shows, if we don't talk about CO2 equivalents, which are less easy to capture, in real tons, we have an abatement of roughly 2.7 tons less CO2 per 1 ton of product. And this without any quality reduction of the material that we can drop in as a solution, thanks to the super cleaning process. Yvonne?
Yes. Let me tell you a little bit about the RecyClass guidelines. RecyClass is an association of the total value chain. It contains the chemical industry, recyclers, brand owners, packaging designers, and the converters. This RecyClass association, they make guidelines for recyclability of packaging. It's very important to understand that it's about recyclability of the end product. So when the recycler receives his waste, is he capable of sorting it? Of course, very known is the recyclability of the PET bottles. RecyClass is putting it in 3 categories: full compatibility, limited compatibility, and low compatibility. For example, we all know now that multi-layer packaging has a very low compatibility. RecyClass has done an extensive research for PS, and we are then also very happy to receive the results that a polystyrene yogurt cup is fully compatible. That means that the recyclers can sort the PS yogurt cup easily. These RecyClass guidelines are used in the packaging design world in combination with the brand owners, often, of course, in the fast-moving goods industry. They have an online tool, and many packaging designers, they put in their packaging design and they check in this tool the recyclability of their packaging. So we're very happy to see that we now get this green traffic light. For us, this is really a big achievement, and this will help us in our circular economy, in our objectives, everything we will have shown you today. This brings me slowly to the end of the presentation. This is a summary of our press releases. As already mentioned by Stephanie, we have submitted the Super Clean petition, not only us, NGR, INEOS, Styrenics Circular Solution, and we're really awaiting the EFSA to come with their final verdict or their final conclusion on these petitions. Collaboration with TOMRA, very important for us, because TOMRA has a very close contact with the recyclers, and together with them and the recyclers, we could develop this 99% purity already coming from the sorting, which is of course very important for the input for the post-consumer styrenics. Then Syrup France and Pulp Packaging, they have done trials with our eco products and they have been very successful so far. So we're delivering on the promise that if we make eco products, it's a virgin-like drop-in solution. And if you really want to see everything again, we have a beautiful video on mechanical recycled polystyrene on YouTube, which you can watch again. So where are we today and where are we moving to? Today we presented on the mechanical recycled polystyrene. To summarize, post-consumer recycled 100% polystyrene. Of course, in the future, we'll work on other non-food grades. We already have bio-attributed polystyrene with 100% renewable feedstock source. It's now available. We do the mass balance approach and we have the ISCC Plus certification. Then as shown in the slides, we expect commercial sales from our depolymerization factory starting in 2024. But earlier, we already have available solutions coming from the mixed waste pyrolysis sources, as we've already shown in the beginning. Both also will go on the mass balance approach and again the ISCC Plus certification. I will not go one by one through all the products, but this is to show you the summary that we have developed more eco grades than polystyrene only. We shortly already touched the Terlan Eco, which is an ABS coming from post-consumer recycling. And in the full list, you can see our other eco solutions. If you want to know more about it, please contact your account manager or send an email to our info email address. I think this is the moment we can go to the Q&A. And we have Louis also in the call who will help us to guide us through the questions you've sent us.
Good morning. Good morning, everyone. And thanks a lot, Yvonne. And thanks to everyone who's been using the Q&A function in the chat to send us some questions. I've collected a few of them here. So let's just jump in and run through some of them here. So the first question that I have here is that you mentioned that you are working with OEMs and brand owners. Have they already made some trials with the mechanically recycled PS material? The answer is yes, they have. So several brand owners have already completed trials with our mechanically recycled polystyrene. The feedback has been very positive. Lots of them have confirmed, the converters and the brand owners have confirmed that the material performance is comparable to the virgin grades that we supply, and therefore we can really offer a true drop-in solution into their processes. So in fact, we already have some additional communications on this topic with some of those converters and brand owners that are already planned. So keep an eye on our website there to learn a little bit more. Got another question here. Do you plan to show recycled polystyrene material at the K Fair? Yvonne, can I hand over to you for this one, please?
Yes, of course, we're going to show that. Our total K Fair booth will be dedicated to eco solutions. So you can see there the polystyrene solution, but you can also see all our other solutions we've built on the last 2 years. And we are really happy to welcome you at our booth and explain more face-to-face about our solutions.
Great. Thanks, Yvonne. Yes, hope to get the chance to meet some of you at the K Fair. So the INEOS Styrolution booth is located in Hall 6 at location D28. So hopefully see some of you there. Another question here. When will the mechanically recycled PS be widely available on the European market, and what volume or capacity will be available? Okay, I will take this one. So as mentioned by Yvonne and Stephanie during the presentation, in fact, we already have a pilot line running today to produce some certain quantities of mechanically recycled polystyrene, and that's enabled us to move forward with trials and getting our material approved by the brand owners. But in the background, we've also been working very hard on efforts to kick off projects to ramp up capacity. And I'm excited to share that details about capacity and startup date will be the subject of an announcement to come soon. So eagerly looking forward to that. And again, keep an eye on our website, and there are some exciting announcements to come there. Okay, and the next question that I have here, what do you mean when you say styrenics made for recycling on the title slide of your presentation? Okay, so I think this is referring to, on the first slide, yes, we say styrenics made for recycling. Stephanie, could I ask you to maybe give a bit more background information about what we mean when we say styrenics made for recycling?
Yes, for sure, Louis. So as I have shown you on that slide, I guess you recall, with the 5 different routes, styrenics, and more specifically polystyrene, has different options to be recycled. We can look at the mechanical recycling. I will drop some further words on this because it's really made for recycling and really mechanically. But we as well have the depolymerization route, which we look at actively as well, or the advanced feedstock recycling. Mechanically recycling for polystyrene does not require any downcycling, which can be the case for other polymers. Polystyrene can be recycled with no sacrifice in properties. As we told you, it can be recycled back into food contact applications. This is due to the different process steps as explained before, but why is all of this possible? It's possible because of the intrinsic properties of polystyrene, and in particular, the fact that it is a low diffusive polymer. This means that it is less likely that anything migrates into the material, and also less likely that anything migrates out of it. So it makes it well suited for mechanically recycling into food contact applications, and that's what we're basing our efforts on. And in terms of sorting, it's the most sortable polymer. We can get the high purity thanks to the different sorting steps, as indicated by the numbers we have shared in the presentation. 99% is possible by using existing technologies. It is easy to identify. We use NIR technologies, for example. They can do that easily with polystyrene. So that allows us to give a really high purity material.
Perfect. Thanks a lot, Stephanie. And the next question that we have here is, why are the RecyClass guidelines important for INEOS Styrolution? Yvonne, you presented a little bit on RecyClass. Can I ask you to tell us, why are the RecyClass guidelines important for INEOS Styrolution?
Yes, these guidelines are important because it's an independent, objective judgment on the recyclability of polystyrene. And it's done by the full value chain. So it's in cooperation, as I explained, with the brand owners, the recyclers, the chemical industry. And that makes it important for us because it's supported by recyclers, because at the end of the day, the recyclers have to do the work for us to sort it out. But it's also important that we know that it's used. You could also call it at the beginning of the value chain when the packaging is designed. And we know that many design agencies use this online tool or via another consultancy or directly via RecyClass, and that nowadays it's really important that you have a good RecyClass definition, or how to say, positive judgment about recyclability. And this is also something in the future the European Commission will look at. It will be one of the discriminators to make a successful packaging design. Back to you, Louis.
Great, thanks a lot, Yvonne. Next question that we received here, from where do you source your feedstock? So Stephanie, can I ask you to address this one?
Yeah. So as indicated already during the presentation, we want to get back the yogurt cap from your bin at home. today we develop several cooperations with recyclers and waste collectors across Europe. So for our current food contact mechanically recycled polystyrene, we focus on the household food packaging waste from the separated collection schemes, waste schemes. As indicated during the presentation, everything which goes into the grey bin today goes into incineration or landfill. So we work in order to make as well a change in that. But today, for example, in Germany, we work with the yellow bin companies active in that area. And current sorting technologies can easily sort this polystyrene out. And then we continue contributing, thanks to this effort, to the European circular economy ambitions. I think that's important to stress it. That's a way to tackle the ambitions set by the European Commission.
Absolutely. So Europe has been very clear with the direction that they want to go to here. So it's important that we already start today to contribute and work towards that. And I think INEOS Styrolution is doing some really good work there. I have another question here. I have read about your cooperation with Indaver. Is that mechanical recycling? Now this one I can take. So indeed, we had a communication not too long ago about a project that we've been working on with Indaver. No, in fact, that is not mechanical recycling. That cooperation is based on an advanced recycling technology known as depolymerization. So earlier in this presentation, Stephanie showed the various different technologies that can be used to recycle polystyrene. And we've been focusing today on mechanical recycling, but in fact that Indaver announcement was related to depolymerization. So depolymerization, the starting point is polystyrene waste, and then using this technology, you can transform polystyrene back to its monomer, styrene monomer, and then we can use that directly in our processes to make new polystyrene or even other styrenic products as well that use styrene monomer as a basis. So this indeed is an exciting project that we're looking forward to kicking off that work with Indaver and starting to be able to deliver material based on that depolymerization process as well. Okay, looking at the time, I think we maybe have time for one or two more questions. So what do we have here? Today's presentation is on polystyrene. Do you have mechanical recycling projects for other polymers? Now, Yvonne, I know that you've been heavily involved in some of the other work that we've been doing at INEOS Styrolution. So can I ask you to address this one, mechanical recycling for other polymers?
Yes, with pleasure. As already mentioned in the presentation, we started all our mechanical recycling activities with the waste, with the electronic waste, and we have learned a lot from that. This recycled ABS we use in our Terlan grades, but also in our Novodur grades, so in our specialty grades. And we go waste stream by waste stream to explore what we can do with mechanical recycling. So in the future, we will also look at end-of-life vehicles. As Stephanie explained, we're now looking at the household waste stream. So yes, we have different products already based on mechanical recycling, polystyrene and ABS and our specialty grades. But for the future, please expect more, because we will explore many different waste streams to build on our mechanically recycled products.
Perfect. Thanks a lot, Yvonne. I think we have time for one more question. So on here, what can you share about your cooperation with TOMRA? Stephanie, can I ask you to answer this one, please?
Project-related question. Yes, Louis. So TOMRA is our partner with regards to technology for the sorting steps that I described to you before. So TOMRA is a technology provider for NIR technology, sorting polystyrene material, for example, from any other material. TOMRA is as well the company that has developed, they call it GAIN technology, which is the technology we rely on to separate food packaging from non-food packaging material. So that technology is based on object recognition and uses some aspects of artificial intelligence. Sorry for that one.
Perfect. Thanks a lot, Stephanie. Conscious of time, so I would suggest that we end the Q&A here. So thanks to everyone that sent in questions. If there are any further questions, you'll see an address on the next slide that you can contact us at. And Yvonne, can I pass back to you for some closing words?
Yes, thank you all for joining this webinar. It's always a great pleasure for us to explain what we are doing or which projects we are working on. I all wish you a lovely Friday and an even better weekend, and hope to see you soon. And as Louis already said, really hope to see you face to face at the K Fair in October in Düsseldorf. Bye.
Thanks a lot. Bye-bye, everyone.
Driving success together.